continuing on with this intro to research. The last time we talked about the differences between science and pseudoscience, and I had some references to Carl Sagan and some different aspects here with the two columns of a statement maybe that is scientific and a statement that could be looked at as pseudoscience, or definitely probably is pseudoscience. Again, there's maybe some background of science behind it, but there's some vague claims, might be some unsubstantiated claims that are put forth. There's really no way to continue to test it, possibly. So we will continue on now. So the scientific explanations, there's some characteristics to them. They are empirical, so there's some sort of evidence that is there. There's some sort of data, and that data can either be quantitative, it can be qualitative, but there's some data there that we can look to and then make comparisons to maybe different studies in the future, different data that comes out. So there is evidence that is part of this. There's not some opinion or some strange thinking going around it. It is evidence. It is hardcore evidence that we're actually looking at. It's not necessarily faith or some belief. It is what is there. It's written down. It's in the digits or the ones and zeros within the computers, some sort of evidence. It's also rational, so it's logical. We can maybe kind of go back to Occam's razor. There's some different interpretations of Occam's razor. Pretty much the simplest explanation is generally the one that probably is the right answer. It might not necessarily be the exact thing that Occam's razor really is, but you have to think about some of this stuff sometimes. Is it logical what the conclusions are, or is the data logical? For instance, if you have a piece of data, I'll give you an example. When we were doing a lot of environmental research when I was in grad school, sometimes the computer would spit out a skin temperature of like 150 Fahrenheit. Sometimes it could be like 100 degrees Celsius. Well, that's not very logical because if your skin temperature was anywhere near 100 degrees, it doesn't matter whether it's Fahrenheit or Celsius, it's wrong. So obviously that data isn't logical. You need to go back and figure out what happened here. Well, just a glitch in the software, or if you're maybe doing some major calculations and for whatever reason a number comes out completely wrong. For instance, VO2, if you start to calculate VO2 and it comes out to 358 ml per kg per minute, we know that that's probably not right. Maybe a thoroughbred horse could have a VO2 that high, but certainly not a human being. At least none that we know of are going to have anything that high. I guess in the same breath too, if it's say 42 ml per kg per minute, that sounds great. But if it's negative 42, that doesn't sound right either. So again, everything needs to be logical, rational with this. It also needs to be testable. That's the whole premise behind this. You need to be able to test it, have rigorous standards behind it, and also retest it. You need to have the ability to go back and do the exact same thing and see if you have different results or the same results. And it doesn't have to be you per se, but it can be somebody else. It needs to be able to go back and to be able to try to replicate the results. And parsimonious explanation with the fewest assumptions. And also with this, not just assumptions, but a lot of biases need to be taken out as well. So, but fewest assumptions, what happens when we assume, ass out of you and me, blah, blah, blah. Also, the general explanation without limited circumstances. Now, this one can get a little bit funny because there are some certain scenarios where you might be studying something under certain limited circumstances that may happen, such as maybe increasing VO2 a great amount, or maybe lowering heart rate very, very significantly within a short period of time. There could be some variations upon the training that could be done. But in terms of the limited circumstances, meaning that, at least in this case, it needs to be able to be replicated throughout the general population for the most part. But again, there's going to be some instances possibly where only a subset of the population, a very small percentage of the population, may actually see that increase or decrease or whatever the change may be. But in general, it needs to be general. Tentative, willingness to admit faultiness and also change the conclusions. This is a very, very important part of the scientific process. We need to be able to stand back and look at our own research and be able to admit where we were wrong. Maybe the methodology, could be the subject recruitment, whatever it might be. And also, if we were wrong, maybe about the data that we collected, the data analysis itself, and change our conclusions. Maybe we replicated a study that we had done previously. We need to be able to say, yep, we were wrong, and we're going to change our conclusions from that. That's just kind of the way the scientific method works. And the same thing is if you or somebody else replicates a study and comes up with different results and then continues to get different results every time you replicate it, the original person who got the initial result, which was different than everybody else after them, they need to be able to step back and say, yep, I did something wrong. We need to change the conclusions on this. It's part of the scientific method. So there's a lot of humbleness in science. And the rigorously evaluated. So it's reviewed and reproducible, kind of going back to the last point. That's the whole premise behind us. We need to be able to reproduce it over and over and over again. If we cannot reproduce the results, something's going on there. Either there's non-significance or there's such a great range of variability between subjects, maybe possibly between the time points, whatever it might be. And what I mean by time points, maybe the time of day something was tested, could be the equipment, whatever it might be. It needs to be reviewed and also reproduced. So a little bit more about the characteristics of the research. So we have the systematic. So there's a plan, you identify it, you design, collect data, and evaluate. That's the systematic portion of the research. You have the logical, which is examining the procedures then to evaluate the conclusions. You're collecting data and you have a methodology. You collect that data based upon that methodology and the equipment that you're using. And then you evaluate, analyze that data, come up with conclusions. The empirical then is the decisions that are based upon the data. So based upon empirical evidence. A lot of times you'll hear people talk about empirical evidence. That's the data that we're using to base our daily lives on, possibly any type of training methods, whatever it might be. We're basing it upon empirical evidence, that data that was collected. Reductive. So general relationships are established from the data. And this is where we get the discussion section, which we'll get into later, discussion section, and then also the conclusions. Then the replicability. So it needs to be able to be replicated. So the actions are recorded and they are then disseminated. How that research was actually done, it's disseminated amongst everybody. It's written in a paper, written down somewhere where somebody can then take it and try to reproduce it and replicate it. So we have this difference between basic and applied research. So the basic research, we have confirmation or disconfirmation of theoretical or empirical positions. So the goal here is theory driven. You're trying to come up with either a theory or hypothesis is really what you're looking at. You have some idea of, let's see what happens when we do this, or let's see what happens when we change this. And we have an idea of what might happen, and we're going to test that, and we're going to try to prove it wrong, basically, is what we're trying to do. But if it happens to be correct, fantastic. Now, the approach to this is stringent testing procedures in a laboratory. The applied research side of things, it's based upon real-world applications. So the goal here is immediate solutions, practical solutions, and the approach is more in the real world. For instance, if you were going to look at maybe certain types of training methods or running speeds or VO2 increases, whatever it might be, if you were going to look at that from the basic point of view, the basic research, you would do that in a laboratory under a controlled setting, the environment itself, the temperature, the humidity, the wind, whatever it might be, is all controlled. And that's where you would do the basic research. The applied research then is going out into the field, going out onto the track, cross country area, wherever it might be. And that's where you would start to study people in the real world setting then. But most of the time, you're basing some of that application or the applied research that you're doing off of basic research that has already been done. So quality research, there are some things that need to happen here. Quality research involves identifying and delimiting the problem. So being able to identify what's the issue? What are we having problems with? What question has not been answered? That's really what we're trying to find out. Then from there, you search, you review, and you write about the literature, everything that has been done previously, or try to find everything. Every once in a while, you're going to miss some sources. It's difficult to get every single peer-reviewed literature that has been done on that one specific topic. Sometimes there's thousands of papers that are done on it, and you can start quoting or referencing a lot of papers. There's only so much space that you have and only so much time that you have. You can't reference all of them, but there could be some research topics that you don't have a lot of sources. You may only have a dozen, couple dozen, depending upon what it would be. But you go back and review as much as you possibly can and figure out what everybody else has done. And is there some consensus? And what is the problem? Maybe the question that you have has already been answered, but maybe in a different way that you want to look at it. So let me give you an example of that. A lot of times in caffeine literature, when I was doing some caffeine research, most of it was coffee, or there were some maybe capsules that people were swallowing. So pills, caffeine pills. One of the novel aspects to a lot of the research that I was partaking in, assisting in, but also directing then later on was caffeine gum, which is a little bit different. It gets into the bloodstream quicker, much quicker, about a half hour or so, 40 minutes quicker. It does last, I don't know, probably about the same amount of time, but you can also take more of it, and it's more regulated in terms of, or it's more, there's more consistency in how much caffeine is in one piece of the caffeine gum versus if you're drinking coffee, it could be a huge variety of numbers that you're going to get in terms of how much caffeine is in that coffee, depending upon where you get it from, how it's brewed, what types of beans, where the beans are coming from. There's a whole bunch there you can get into, but reviewing the literature and finding what people have done before you, and then what are you going to do, and how does that compare to what everyone else has done? Specifying and defining testable hypotheses. So what do you think is going to happen? And how are you going to test for it? What subjects are you going to have? When are you going to test people? What data ultimately are you going to collect? Is it heart rate? Is it blood pressure? Are you going to do blood draws for whatever parameters you're looking at? What is it? Is it psychological tests? Is it certain types of questions in a survey study? So then designing the research to test these hypotheses then. So that's kind of the whole point. You've come up with a methodology to test whatever the hypothesis is that you think is possibly going to happen or not happen. Selecting, describing, testing, and treating the participants. And participants are the subjects. I know there was when I was in grad school, I had a professor who really didn't like the term subjects because he said it was, it was not politically correct. I don't know. We still use subjects to this day, and that was, 12 years ago, whatever. But subjects, participants, whatever you want to use. They are volunteers in your study. And these are volunteers in your study. Most of the time, these people are volunteers. Sometimes when you have some observational studies, they don't know they're being studied, which is kind of a good thing. But you're not going to do anything invasive with them. You're just going to be watching maybe a certain group of people. You're people watching. So you're watching a certain population. But what are you doing with the subjects? How are you selecting them? Who are they? How old are they? What race are they? Where are they from? How tall are they? How much do they weigh? What types of testing are you going to do with them? Once you test the subjects, then you need to analyze the data. So you analyze and report the results with that and go through. There's a lot of different ways you can analyze and review the data. So Excel can be a popular one. Sometimes it's just a simple percentage of how much has changed or certain percentage of the population that showed this. But you could get into some other analyses that are maybe a little bit more difficult, where you maybe need something a little more powerful in terms of computing, which is usually SPSS in our field. There's a couple other programs that can do the statistical analyses, but SPSS tends to be one of the more popular ones. And we'll get into maybe a little bit of that later on, but you need to analyze that data then. Then you need to discuss the meaning and the implications of the data and the findings that were seen within that specific population. So that's the discussion section, as well as maybe a little bit of the conclusions there. But discussing what you're wanting to do, how you did it, what actually happened, and you need to interpret that. What does this all mean? Why did you see certain increases or decreases or maybe no changes? Why was that? So start to discuss that. And some of that is going back to the literature that was previously performed, or the studies that were previously performed in the literature review. So speaking of the literature, making sure that you're reading the research, the peer-reviewed data and research that has been published in this specific area and in your field just in general. So become familiar with those relevant publications. Read the studies of interest. Now, when you're going through a peer-reviewed journal, you don't have to read every single article. I absolutely don't. I just don't have enough time. I also like to read in my own time. I just don't have enough time in the day to just continue to read every single article. Look through the titles. Which ones stand out to you? Which ones maybe are specific or at least close in relationship to what you want to study? Or maybe just in your interests. And then you can look at the abstract. The abstract should be written in a way where it's nice and concise, and it tells you what they did and what the general conclusions are and discussion is. And then if you're more interested, you can then start looking through the details of the entire body of the work. But read the studies of interest. So read as a practitioner would. So you're looking at this from a researcher's point of view. How would you go about doing this differently? Or maybe what mistakes do you think that they made? What do you think that they did correctly that you want to maybe try to replicate, whatever it might be? But also, how would you apply this to a real world setting then? How would you apply it to sports or training or some type of therapy? The abstract, again, I referenced the abstract before. The abstract is a fantastic part of a journal article because, again, you can't read you could read all of them, all of the actual papers and detail the entire body of it, but usually most people don't. Some people do, but most people don't. But read the abstract first. It'll tell you a pretty good synopsis about what happened. Again, some of the nitty-gritty details might be left out, but the general aspect of it is there. So don't worry too much about the statistics. Statistics are usually up to snuff once they are peer reviewed. There's usually somebody that is reviewing the articles that is really good at stats and making sure that these people have performed the right statistics. And also the individuals that have worked on the study have tried to make sure that they've used the right stats. So don't worry too much about the statistics. It can be, if you're not a math person, it can be a little bit difficult. I'm actually interested in math, but statistics for me, my head just explodes. I know enough to be dangerous. I say that, but I probably know more than what I think I know. But there are some people that are far and way better than me at statistics. But most of the time, the studies that I've performed, it's pretty simple stats that I've been able to use. It's not too hard to enter the data correctly, and we'll get into some of that later on when we get into SPSS and Excel, because sometimes it can be different. If you enter it the wrong way, you're going to get completely different analyses. So, but just don't worry too much about the statistics. You can figure that out later, or we will figure that out later. But again, going back and being critical but objective to what the research is showing, maybe say, yeah, I think they made a mistake here. I don't think they used the right analyses. I don't think the conclusions or the discussion was correct, but being objective. Maybe you have some research that shows that this is what should happen, and they showed something completely different. Just being objective about it. Okay, unscientific methods of problem solving. This can go into the pseudoscience category sometimes, probably most of the time, but the tenacity. So this is the tenacity is actually in the one textbook that I'm using. Actually, I got it right here because I'm going to actually show you. Oh my goodness! If you're watching the video, the research methods in physical activity, there's a couple different editions of this. Again, it's not required for the course, but the textbook describes some of these, and I thought they were pretty good. So the tenacity is basically described as, it can include superstitions. And we all kind of have, well, I'd say most people probably have superstitions. I don't want to say all, I don't want to paint a blanket over everybody, but a lot of people have superstitions, especially athletes. If you know some baseball players, especially pitchers are probably the worst at this. Have some superstitions where they have to put on their spikes a certain way. They have a certain routine when they're warming up. They're not going to step on the foul line, or maybe some pitchers want to step directly on the foul line as they're coming in from, at the end of the inning. There's some really weird superstitions with this. There's a lot of superstitions in training, in weight training, that probably aren't very scientific at all. So as tenacity, this is basically the superstitions or something that is just not, it's forcefully thinking that you have the agency to be able to control every situation if you do this one little thing, and that's it. The next one, intuition. Oh, we hear about intuition all the time, right? We need to make sure that we are in tune with our intuition. That way we know when we come upon a situation, we know what to do based upon what we feel in our gut. But this common sense that we feel with our intuition, actually a lot of times probably isn't correct. It may be 50-50. It's definitely not a very high percentage. It's 50-50 at best, probably. So this common sense that we have actually tends to be false. And some of this even goes back to memory. Our memory is terrible. I've seen, and I haven't looked this up, so you can look it up if you want to. But the reason eyewitness testimony is not a very good thing to have in court. In fact, it's dismissible in court because people don't have a very good memory. Our memory fools us most of the time. We think something happened Even if it was yesterday, a week ago, 10 years ago, we think something happened the way it did in our mind, but it probably did not happen that way. In fact, if you go, I've had this happen multiple times. Look in old family videos, back when we had big, huge VHS camcorders we had to put on our shoulders and everything. I, in my mind, had an idea of how something happened, whether it was maybe a pee-wee football game that I was playing in, or a family get-together, maybe Christmas or whatever. I had an idea of what happened, but then I go back and watch the video years later, and I'm like, wow, that's completely different. I said something completely different. Different people were in the room or in the scene. Maybe we were playing a completely different opponent than who I thought. Our memory is actually pretty terrible. So therefore, our intuition is based upon the memories that we have. And it's usually not pretty good. It's not great. It can help sometimes, but again, is it 50-50? I don't know. Our intuition's probably not the best. We need to base everything off of data. But anyway. All right, authority. So don't like what others find. This one, a good example of this one is football and head injuries. There are some people way back when they were, well, I guess it wasn't way back, it was kind of recently, when they were finding out and bringing out the fact that, football is causing head injuries, pretty bad head injury, especially over time. And there was a lot of people that were saying, no, it can't be. This isn't right. This is incorrect. These doctors really aren't studying what they should be studying, or they're incorrect in their analyses, because they just did not like the conclusion. They didn't like the fact that they found something that could threaten their worldview. And especially the people that were in charge of the NFL and maybe certain other football leagues. There was a little bit of authority going into that people in the NFL, around the NFL, even fans, did not like the conclusions. It was changing the game too. It was changing the game completely different. If you look at the game now versus 20, 30 years ago, it's different. I mean, there's a lot of things that are the same, but there's a lot of things that are completely different because of the knowledge that we've gained from those studies based upon the head injuries and the analyses that we were able to get. All right, the rationalistic method. This one's kind of weird too. This one goes into an actual fallacy too, being that, for instance, basketball players are tall in general. So Tom is tall, therefore Tom must be a basketball player. Not necessarily, right? That's a poor conclusion to make from that. Just, it's almost like judging a book by its cover type of thing. All right. Now the scientific method of problem solving. Step one, you got to develop the problem. You define it, delimiting it. And then step two, formulating the hypothesis. What do you think is going to happen? Or not happen, possibly. Step number three, gather that data. And then step number four then is analyzing the data and interpreting what it says, interpreting those results. Now, there's some other steps here that we have, but the core of the problem solving are these four steps, but there's some other kind of sub steps in there. You can go into writing the paper and then publishing it and all the other stuff after step number four. But for the most part, step 1, 2, 3, and 4 right here is the core of the scientific method. And we can get into things like the independent, dependent variables. The independent variable, this is the one that the researcher is manipulating. So when you're looking into the hypothesis, that's kind of important. Also, the dependent variable, that's the effects from the independent variable, the stuff that you're going to be manipulating. We'll get into some of this here later on as well. Now, the types of research, there's analytical and descriptive. The analytical you can look at from like historical. So these are facts that are present on maybe like state of affairs, stuff like that. The philosophical, so based upon facts that try to create some sort of theoretical model, maybe about how somebody should live, what we should do in certain situations, how we should treat others. There are reviews. You can look at this as like literature reviews about a certain topic. And then we have the research synthesis or the meta-analysis. Now, a meta-analysis is a little bit different than a regular literature review and also a regular research study, in that a meta-analysis actually takes data, similar data, from multiple different studies and combines them into one great big study and try to get one great big conclusion about what is happening. So you have all these different pieces around the journals, and someone gets that data. They can contact the researchers, say, hey, can I have your data? I'm going to get some meta-analysis. I'm going to combine it with this study and this study and this study, or at least try to, and see what we can come up with. And that's what they do. And so it's an analysis. It's this big analysis on multiple studies that have been done. So instead of just taking one piece of one study and saying, that's the conclusion and that's what we're going to live by. No, we're going to take this one and we're going to take this one and then this one and this one. They all have similarities. They were all looking at the same things possibly. And we're going to put them together, all the data, then analyze all of the data from all of those studies, and then come up with a bigger conclusion. Then we have the descriptive research, which this is the questionnaire type of stuff. An interview could be an in-person interview, could be online now, possibly. And then you have a normative survey. So these are maybe like fitness tests for large populations, be an example of that. So there's some standardized testing for those normative types of research. Now, some other types of descriptive research, you have case studies. A case study is basically just one subject, maybe a group, maybe a small group, and you're studying that one specific person. Might not be very many trials, a couple trials possibly, but you're just looking at that one person and trying to see, a lot of times this is trying to figure out, is there a there? I know that's a weird saying, but is there something there that you can make a bigger study out of? What types of data can you get from it? Observational research, this is just observing. You're observing a certain population. You're not actually, you're generally not manipulating a variable or having some sort of independent variable. You are just simply observing how somebody reacts. And a lot of times it's in the real world setting as well. Not always, but a lot of times. Then you have correlational studies. In correlational studies, you may have heard about these too. Again, correlation does not equal causation. It's as one thing increases, another one either increases as well, or one increases, the other one decreases, or both decrease at the same time. They're just related to one another. The two variables, or maybe a couple of different other variables as well, might be related to one another, in that when one changes, the other one also changes at the same rate, either in the same direction or the opposite direction. But again, it doesn't necessarily mean that it's cause and effect, but they're still very important, because the correlational studies were very important in epidemiological research early on to determine, is there a relationship between smoking, or maybe poor exercise, or poor diet, maybe high-fat diet, whatever it might be, and heart disease, or diabetes, or cancer. So the correlational studies were very important, are still very important. Now, here's the thing about correlational studies, though. You may have heard me say this before. If you have, say, maybe a couple thousand data points with a correlational study, it's still just correlation. However, when you get to some of the studies, some of the levels the studies are at now with the epidemiological research with heart disease, diabetes, we're talking tens of thousands of data points, and there's still that major correlation there. You can start to draw some conclusions where there possibly is a cause and effect. The correlational study and data points get so high, you're like, yes, there's something going on here. It's just not, they just happen to be related. There's generally a cause and effect. Not always. There needs to be more definitive data to determine that. Epidemiological research, I mentioned that before, a lot of times this is correlational. Doesn't have to be, but a lot of times it can be. So that's determining, is there a relationship between a certain behavior and the risk for developing a disease, or maybe not developing a disease. The experimental research, so this actually establishes the cause and effect that we don't usually see in the correlational studies. And the last one here, we got the qualitative research, and this uses a different paradigm. So it's a qualitative, we're basically using words. Essentially, we can start to use some numbers. There's some people that are really good at qualitative research. I haven't dived into it a lot. I didn't do any qualitative research. A lot of psychological research can be qualitative, and you can assign some numbers to different things, maybe Likert charts. We'll get into that here later at a different time, but and we'll get into maybe a little bit of qualitative research data. But we have the qualitative side where it's less numbers and more of an explanation. So we can look at the path that we're following here in terms of the research. So we have a problem, and so you're identifying a problem, you're asking a question, you're reading the relevant literature with that, and then you can have ways to get to a hypothesis. Again, you get the theoretical, get the deductive reasoning, the empirical evidence, and the inductive reasoning. Get to the hypothesis. What do you think is going to happen? Then you have operational definitions. So that would be things like the participants, the time of day you're going to test them, where it's going to happen, the equipment that you're going to use, what actual specific data are you going to use, and how are you going to test the subjects? So the methodology, essentially. Then once you get through the methodology, you recruit the subjects, you write all this stuff up, you recruit the subjects, then the subjects come in, you collect the data on the subjects, that's the data collection, and you analyze the data. Now you have the findings. Once you have the findings, then you can go through and start to look at what actually happened. Okay, these findings say this, and let's go back to the literature. And how does that fit in with the previous literature that has been done? Why do you think that it happened this way in your study? Why do you think there was an increase, decrease, no change? Possibly even talking about what mistakes could have been made. Were there any faults in the methodology? Things like that. And you can always go back then, once you get the discussion, you can find a new problem and review the literature again and go through the process over and over again. And that is the scientific method, basically. It's essentially never ending. All right, so let's get into this with the parts of the thesis. And this kind of will possibly lead into the next chapter then with defining the problem. So you have the proposal. So you need a research plan with this. That research plan would include the introduction. So that's the problem, the hypothesis. You're just introducing the topic. So that would be looking at basically a chapter 1. Chapter 2 would be the literature review. The literature review is what has been done previously. And there are certain ways, and I can get into this with you as well, certain ways of setting it up. It doesn't have to be exactly the same as somebody else, but there are certain ways of setting it up to help with the flow of the literature review. And obviously, it's going to be a little bit more condensed if you're doing a study. If you're doing just the literature review, that's going to be much longer. It's a broader literature review, so it is going to be much longer. And making sure that it is set up with titles and subtitles or sections and subsections is going to make it flow much easier. And you don't have to write it in chronological order. You can start mixing, matching pieces into it. And I'll show you that later on. The methods then are next. So these methods include who you're going to recruit, what instruments you're going to be using, what is the instrumentation, the procedures that you're following, and then the design of the study. Is it within? Is it between? And then you're going to have the data analysis with these. How are we going to analyze the data? And then when you complete the thesis, that's the results. And then the discussion and the conclusions then will follow up with that. The discussion section generally is the biggest section. The conclusions a lot of times is only maybe a paragraph, maybe 2 paragraphs. The discussion section, that's kind of the big part of the paper. That's where you start to discuss what happened, why it happened, why you think it happened, based upon scientific knowledge of previous studies, but also your study as well. So then the conclusions is the conclusion is basically a very short summary of what happened. So we'll end it there. That's kind of like the last little part there of the intro to this research. Next, we're going to actually get into developing the problem and using the literature then to help you get going with this. So that was the intro portion of it. If you have any questions, let me know. If not, I'll bid you adieu. Thanks for watching, and take care. I never know where to look. Like my video is right there. My camera is right there. I'm always looking at me. Why am I looking at me? Stop looking at me. I'll look at you. You there, Mr. Sensor.